Welcome to the presentation part 2 of our one-digit DVM troubleshooting. Here we have the schematic, complete schematic, made up in Multisim with our DAC, our comparator, and over here we have the D latches and our 747 converter to 7-segment and all the interconnecting circuitry. Here we have the output of the DAC in our comparator circuit, and this is our differentiator here where we're supposed to make the spike. This is the first place we'll measure right here coming out of the DAC, and we should be getting a positive going stair step. Here's our unknown value, and we're going to get a different output from these areas here, but this area here is our differentiator. It's going to produce our spike. Here's our output of our DAC and our comparator circuit. The red here is our positive going stair step. The yellow is our unknown voltage, and where these cross, that's an important part. This changes here is that past our comparator before the capacitor, and this spike here is our differentiated waveform. So this is what we're looking for here. As it crosses, our comparator changes and our RC circuit produces this spike. This spike will be converted into our latch signal. Here's our circuit with some tampering done on it. I broke this connection here. This is something I could do on our board, and we're going to take a look at the output. Okay, here's our good stair step, our unknown voltage. We're getting a good output of our comparator, but you see we have no differentiated waveform because we cut that capacitor out of the circuit. Here's another troubleshooting circuit, the same area, but what I've done is I've cut this resistor off from ground. And let's take a look at the waveform. Here's our circuit again. Our stair step unknown is good, and we're getting our output of our comparator. But since we don't have that resistor as part of our RC circuit, we're getting the same output. Anytime we cut the circuit, both sides of that circuit are going to be the same. Here we're looking at a good circuit. This is of the data latches and our 7-segment decoder. And what I'm looking at here is our control signals coming out of our differentiated waveform. Okay, so I could cut anywhere in here, and we need to have two good signals because there's two data latches. So let's take a look at the output. Here's our control signals going into our data latch. Here's one of the inverters. This is the other inverter that changes the side to a pulse that we need. Everything else should be the same, so we should see this trigger pulse at the two pins on the data latch, I believe 13 and 4. Okay, here I'm tampering with the 7447 7-segment decoder, and what I've done here is I have grounded blanking input. Blanking input will blank out the 7-segment LED, and you notice there's no display. So there's couple things we could do to blank that out, and one of them is by grounding blanking input. Here's another typical way to see a blank screen on our 7-segment LED, and that's by cutting the power. That's another way. Here's another tampered 7447, and I added a ground to our light test. LT pin 3 is pulled low, and I have an 8. So there's a couple ways to get 8. We could have one where the unknown voltage is 8. That's pretty much it. So if you see an 8, it's probably the light test. You should try that first. Okay, if we see a missing trace, let's say we're supposed to have a 7 like in this case, and we're missing segment B, I would look for a trace either on either side of this resistor. that's pretty clear that we have a problem there if we just have a missing segment like that. Here we're going to look at our signals looking at this cut trace, and that is going to be our probably B, and we're going to take a look at these signals, so we'll take a look at them now. Here's our signals from the cut trace, and if you look here at red, that's the output of our 7447. It is providing a ground in order for that to light that segment. Okay, since we have power going through our 7-segment LED, this is providing ground in order to light it. So here we have the lower voltage in the magenta here is 2.9, so that is the voltage minus the diode. And here is the open voltage because of the open circuit, just a little bit less than the 5.